How are we all feeling? Yeah? Cool, excellent. My emotional batteries are fully recharged after a very late night last night. My physical battery is less so. So today I'm going to talk to you about passkeys, and we're going to go through them and explain to you why they're a thing and why we need them, what exactly they are, and how you can use them in your apps to provide a better and safer authentication experience for your users. So, if you've never met me before, I'm Tim. I run a company called Broken Hands, and we do ServerSide.swift consultancy and training, so helping clients around the world deploy Swift on the server. But I'm better known as being one half of the Vapor core team, so building and maintaining the Vapor framework. I sit on a couple of work groups for Swift, the Swift website work group and the Swift server work group. And the Swift server work group maintain a SDK for Swift on the server for Passkeys, which is what I originally wrote, which is what this talk is based on. So we're quite interested in making sure that that kind of the new standard of passwords and authentication is available on Swift on the server. I'm part of the ServerSide.swift team at Kodeco, and I organise a couple of meetups in the UK and the ServerSide.swift conference, which is in September. And is a great conference if you're interested in that kind of thing. If you have any questions, I'll be around most of the day, but if you don't get a chance, feel free to reach out to me. I'm 0xTim on all of the social media. So why do we have why do we need passkeys, and where do we come from? So passkeys are all about authentication. And authentication is about proving you are who you say you are. So let's imagine you're in a library and you want to check out a book. You might go up to the desk and say, hey, I'd like to borrow this book, please. And the person at the desk would be like, sure, who are you? And you'd be like, well, my name's Tim. And they go, okay, can you prove who you are? And in this instance, you might be like, sure, here's my ID card, here's my student card, as a way of proving that you are who you say you are. Now, authentication is not the same as authorization. Authorization is about proving that you have the permission to do what you're trying to do, whereas authentication is about proving who you are. So back in the library scenario for authorization, you might go up to the desk and be like, I'd like to borrow this book, please. And the person at the desk would say, let me check that you're allowed to. And you go, well, I'm from the iOS course, and they might say, sorry, this book is only for law students. You don't have permission to borrow that book. But we're not going to be focusing on authorization today. We're only focusing on authentication. And they are quite different. And it's this part here, this can you prove who you are? That's the bit I really want to narrow down into. And it's all about identifying yourself. And we have many ways of doing that. You might have a credit card. You might have an ID badge for your company. You might have a username or an email, even a phone number, or sometimes even an IP address. Depending on the scenario, these different things might be the thing that you use to identify yourself. And part of that is about proving your identity, because it's very easy for me to say, hey, I'm 0xTim, but anyone can say, I'm 0xTim, so how do you prove that? So with credit cards, we have PIN numbers, or signatures if you're from a third world country. And that is a way of identifying that you own that credit card and that is your credit card and that you are that person. With badges, you might have keypads if you need it for the requirements for security and stuff. And some of us use biometrics and thumbprints and fingerprints and Face ID to prove that we are who we say we are. But for most of us, we're used to this kind of thing. A login form with an email or username or something like that and a password. And we all know passwords, we all love passwords, and we all use passwords. So why do we have passwords? Why are passwords a thing? Well, they're really simple. They're very easy to use, and we all know about them. In this great stock photo of people having a great time around a computer, passwords are easy to share. It's very easy to go onto someone's computer and log into your account if you want to watch a movie on your account or you want to play a game or something. They're very portable and it makes them very easy to use. Building passwords is very simple. At the end of the day, you have a form that has 2 fields. You send it to your server looks up that user and checks that the password matches. Now, building a password flow properly is not as easy, but building a password flow is actually very simple. And passwords have been around for millennium. The Romans used them for centuries, and we know inherently how to use them. We're brought up with them. My mum knows how to use passwords. It's very simple. She has the concept and understands it. So passwords are ubiquitous. However, as humans, we're not great at doing passwords. We need things that are easy to remember. And these are a list of the top 10 passwords in the world. And we shouldn't be using them. We also have things like phishing attacks and hacking attacks that make our credentials get stolen, which means that anyone can then use our password and take them and pretend to be us. Which ends up with these ridiculous requirements that we now have of passwords of saying, well, your password might get stolen at some point, so we're going to make you change it every 3 months. And we're going to put all of these rules and requirements around your password to make sure that it's difficult to guess and no one can just make it up. And so you don't use those top 10 passwords. And it gets these ridiculous scenarios where you have to change your password every few months, remember all of these different passwords, and you can't reuse passwords. And how many here have a password that has an incrementing number at the end of it? Exactly. Passwords are inherently flawed and insecure. And we even have comics that have legitimate information on how to write good passwords, which is ridiculous. And do not get me started on security questions. As someone who used to work in cybersecurity, it is incredibly easy to work out this information, either through social media, social engineering, or just going to your website and looking at Facebook. So really, really do not use these in your apps. Please, please do not use them. Feel free to come in, there's seats around if you want. No? Okay, fine. So how do we actually go about securing our accounts? Because we know that passwords are not secure, so we have to add an extra layer of authentication. And so we have different ways of hashing our passwords to make sure that if someone does steal the passwords, they're still secure and you can't just easily get them. So there's bcrypt and Argon2 and PBKDF2, which are different hashing algorithms that are effectively one-way hashes. So that if you have the hash, it's very hard to get the password from that. And we should all be using password managers, such as iCloud Keychain, 1Password, LastPass, as a way of creating unique passwords for every single website. So even if one account does get compromised, all accounts, the rest of your accounts are still fine. But these days, we need two-factor authentication because passwords are not secure. So two-factor authentication is based off 3 tenets. So it's something you know, which could be your security question, your password, your PIN number. Something you have, which could be like your phone, your email account, RSA security key, or something that you are, which is Face ID, Touch ID, biometrics, that kind of thing. There are other security mechanisms for authentication, which they have used, such as in the war, which is pronouncing difficult words which only native speakers would be able to pronounce, but I won't cover that. And so you would have seen things like this when you're logging in. You get an SMS saying, use this one-time password, this 6-digit code that you need to put in. If you're old enough, you'll remember these RSA keys that you used to have on your keychain, which had a rotating number that changed every 30 seconds and you had to put in. These days, these are built into software, and we have them in iCloud Keychain or Auth0 or Google Authenticator. We have in-app approvals to say, are you sure you want to log in? Or even push notifications if it's done well. Or an email link where we send the actual authentication link to your email, because then you are the only person who has access to that email. And these actually are great. And if you have to implement something, you should implement one of these, because it provides a great layer of extra security for your users. But they're all inherently insecure. SIM swapping attacks are a very relatively easy attack where you ring up the phone provider and say, hey, I've lost my SIM card. Can you please send me a new one? And if you can intercept that SIM card, great. Or you just say to the person on the phone, oh, I forgot to update my address. I moved a couple of years ago. Here's my new one. And you'll be amazed at how easy it is to get SIM cards sent to your address for other people. Phishers, there was a big phishing attack a couple of years ago that hit thousands and thousands of big companies, where you essentially get spammed with either text messages or in-app approvals saying, do you want to log in? Do you want to log in? Do you want to log in? And if you send those in-app approvals enough, someone is going to click yes. And there's also phishing attempts where you man in the middle the security code. So if you're saying put this SMS code in, you just put a fake site up in front of that one, they put in the real code, and you just forward in and log in as them. But there is one type of two-factor authentication that is actually secure, which is these little security keys, which you might have seen and you might even use. The most popular ones are YubiKeys, and these are little hardware devices that you plug in that are unphishable. They have a secure enclave built into them that contains an encryption key, and they work really well. But why can't we do this with software? Why do we have to have these hardware keys that we take around? And why can't we do this with software? And that's what Passkeys are all about. So, what are Passkeys? So if you're really interested, you can go to the WebAuthn spec, which is the kind of superset of Passkeys that covers two-factor authentication using hardware security keys and WebAuthn. It's a thrilling read, but it is actually very useful and contains all of the steps you need to implement, but rely on an SDK. But the kind of one line or the elevator pitch is that passkeys are a replacement for passwords that provide faster, easier, and more secure sign-ins to websites and apps across a user's devices. Unlike passwords, passkeys are always strong and phishing resistant. Passkeys cannot be phished. It is not possible to phish them because of the way the spec works. And they are always unique and they are always strong. We take away that kind of requirement of putting the onus on users to create strong passwords and do it in software instead. So passkeys are still use two-factor authentication. If you've ever used a passkey, you will have Face ID come up, which you would have seen. And passkeys are stored on the secure enclave with very restricted access. So you have to go through specific APIs to be able to read them. If you forget your Face ID or you're wearing a mask or something, you can fall back to a password, which is a bit ironic as a replacement. But it's a similar kind of scenario to password managers. You only need to remember the one password that controls access to all your passkeys. And so you remember one strong password, and the rest of your accounts are protected using passkeys. They're also shareable as well. So if you want to log into your friend's device, it works in a pretty unique way, but in an interesting way, and it's quite simple. Essentially, the website brings up a QR code. You scan that with your phone. The phone then makes a secure connection. Well, it first checks with you if you want to authenticate on this website using Face ID or Touch ID. And then it creates a secure connection to the other computer via Bluetooth. So you have to be close to the device, which means that it removes a whole kind of phishing attack avenue. And then the end device communicates with your phone and shares the passkey, and you can log in. And then you're authenticated. So, before we kind of go any further, we need to take a bit of a detour. And we need to talk about crypto, the useful one, because the other one is not useful at all. So, we have cryptography. And in cryptography, there are basically two main pillars. You have asymmetric cryptography and symmetric cryptography. Asymmetric cryptography is where you have a key pair, a private key and a public key. And symmetric cryptography is where you have a shared secret between two parties. We're not going to cover symmetric cryptography today. We're going to look at asymmetric cryptography. So you have your two different keys. You have a private key and a public key. And the private key is something that you own and you keep secret. And your public key is something that is shareable and can be public, as the name would suggest. And they're all based on prime numbers. So your private key usually is comprised of two prime numbers. So in this case, 13 and 7. And you multiply them together, and you get another number, which is 221 in this case. And the idea is that computers are very good at multiplying two numbers together, but it's very hard to refactor that number back into the original two numbers. So in this instance, that's quite simple. But can anyone tell me what the two prime numbers are for getting this number is? Well, if you didn't know, it's these two. And these are actually very small numbers compared to the numbers that are used for private keys in modern cryptography. Modern cryptography uses 256-bit keys, which are comprised of prime numbers that are enormous. And the idea is it's very difficult to go from your public key back to your private key. Almost impossible. I'm not going to get into kind of post-quantum cryptography where things like that are breakable. But in the current state of things, we have a private key and a public key. So the idea, yep, very easy to go from two numbers, very difficult to go back. And you can kind of think of your private key as an actual key. You are the only person who has access to that key. And that key is a way of proving your identity, because you are the only person who has access to that key. Your public key can be thought of a padlock. So you can share this padlock around. It doesn't matter who has access to this padlock. Anyone can use it, but you're the only person who can unlock it because you're the only person with the key. So there are two main things with cryptography. We have encryption and signature verification. Encryption is where you have something, a piece of plain text that you want to encrypt. And anyone can take your public key to encrypt your plain text to get ciphertext. So imagine you have a box, you put your message inside a box, and anyone can use that padlock to lock that box, because your padlock can be shared around. But you're the only person with the key to be able to unlock that box to get the original message back. And that's essentially how encryption works. Signature verification is slightly different. So you take a message, and then you use your private key to create a signature, which contains the message as well. And then you can send the signature to anyone, and they can use your public key to verify that only the person with that private key could have signed that message with that signature. And this is how identity-based verification works across many, many aspects in computer science, and it's how passkeys work as well. Because only the person with that private key can sign that message and get that signature, which can be verified with anyone with the public key. And that's what passkeys are. So there's two different ceremonies for passkeys. You have registration and authentication. So registration, you're on a computer or your device, and you say, I'd like to register, please. And the site or app that you're using or the server will say, sure, send me a public key. So you go away and you go, well, let me create a key pair. So your device will create a private key and a public key. And it will send the public key to the server or to the website. The server then has to verify that, and there's like a 12-step process in the WebAuthn spec that you have to go through to make sure that public key is valid and that person owns that, and there's a bit of back and forth. But essentially, it says, all looks good, and the server saves your public key with your username. So it associates that public key with that particular user. And then the device saves the private key with that domain. And it's that domain part that is really, really important, because that's how phishing attempts or phishing attacks are stopped. So when it comes to logging in, you go to your website, you'll be like, I'd like to sign in, please. And the site goes, sure, here's a challenge for you to sign. Essentially, here's a message for you to sign. So the device goes, okay, let me authorize that with a check with the user and authorize that. So it will bring up Face ID saying, do you want to sign into this website? And you get your Face ID. And it also says, oh, I'll check the domain. Because if the domain does not match, it will not be able to sign with the private key for that domain. So if you have a phishing site that is google.com, but the L is spelt with a 1, as humans, that looks completely normal to us. We don't spot those differences. But a computer is very capable of spotting those problems, those differences, and it will refuse to sign that challenge. Assuming everything's okay, it creates a signature using the private key, and it sends the signature off to the server. The server then takes that public key, verifies the signature, and makes sure only that person can have signed that signature. And it goes, okay, all looks good, you're now logged in. And this is the part that replaces the username and password flow. After this, you can exchange it for an API token, any kind of the current existing authentication experience used for ongoing requests, but this replaces usernames and passwords. So what are some of the advantages? I'm sorry, I have to keep going back to get some water because it was a late night. Passkeys are extremely simple. If you've ever tried them, you will know how easy they are to use. So here's a demo. So I'm going to sign a register first. So put my username in, click register. The device pops up saying, would you like to sign in and save a key? You go, yes. OK, I'm logged in. Click log out. Click sign in. Would you like to sign in? Yes. And you're signed in. And that is the in real time registration and login flow using Passkeys for this particular site. It's actually simpler than passwords because you don't have to put in 2 passwords and make sure they match. And it provides a really nice experience. So it's pretty simple. As I mentioned, passkeys are not phishable. So in the giant phishing attack of a couple of years ago, there was one company, Cloudflare, and they were the only company not to get phished. And all the phishing attacks were not successful against them because they had rolled out hardware security keys across their entire organization, and it was the only way of authenticating with their organization. And so they were the only company that were not successfully phished because they used the same technology behind passkeys. Passwords can be brute forced, so you can basically just go through and go, is it A? No. Is it B? C? And run that many times, and you'll be able to get through most passwords. It will take a while, granted, for most passwords. But with keys that are 256 bits long or even 1024 bits long, brute forcing them will take longer than the entire existence of the universe. So we should be OK for a while. And the public key is public. So this is the other really, really important part of passkeys. With passwords, you have to send the secret across the network to the server. And that can be phished. So if you're on a Wi-Fi network, someone might be able to see that request. With public keys, they're public. It doesn't matter. The private key stays on your device and does not leave your device. In fact, it's so public, here is my passkey for one of my Google accounts. It doesn't matter if they get shared. So if your database gets breached, so what? It doesn't matter. There's no secrets in there for people to be able to use to attack your site. And this is one of the really important parts of passkeys and why they are so much securer than passwords. So how can you go about and implement this in your apps? So for iOS and Mac apps, we have this great SDK called authentication services. So you just need to import this. And then you need to create a type that conforms to AS authorization controller presentation context providing and AS authorization controller delegate, 2 really nice words that roll just off the tongue. And these 2 protocols require you to implement a couple of methods. So the first one is the authorization controller did complete with error. And this is where, say, the passkey doesn't exist, or it failed, or the user rejected it, and you need to handle those error cases. And then for registration on device, you basically need to go through the flow. So you create a AS authorization platform public key credential provider, and you pass in the domain. And this is how the domain is tied to the account on iOS. You then have to go through the flow and create a challenge, which then gets sent to the server. So you ask the server for a challenge, which is something that you sign to prove that you own that private key. And then you make a create credential registration request. And this basically does the flow of signing the challenge for you. So you create an instance of AS authorization controller with the authorization requests, set the delegate and the presentation context, and then you click perform requests. And this will sign the challenge and give you your public key, which you can then send to the server. And it gives you the public key in did complete with authorization, another very well named function. So you have this switch case here on the authorization.credential. And if it is the credential registration type, you have this credential registration object that has the public key and the private key in it. And so you can send the public key to the server as part of the flow and effectively log in. For logging in, it's actually pretty similar. You create, again, an AS authorization platform public key credential provider. But at this time, you create a create credential assertion request instead of a registration request. But it follows pretty much the same thing. You have to get the challenge from the server, which is the signature saying, prove you are who you say you are. Create the same setup. And then inside the did complete with authorization, inside the credential assertion case, this is where you get the login information. And you get a signature. You get the user ID, which is provided to you by the OS. So this is how you kind of link your accounts, and you can get your user ID to send to the server, and the signature, which you can send over to the server as well to prove that you are who you say you are. On the server, because you better bet that I'm going to get some Vapor code into this presentation somehow, there's a really good site called webauthn.guide that goes through the entire process that you need to implement. But frankly, for pretty much every language, there's now a very good SDK you can use. There's the WebAuthn.swift library for Swift under the Swift server org, which if you want to write Swift servers on the back end, you can use. And registration, you have to create a couple of routes. So you create a route for registration, which is kind of the initial route to make credentials. You call begin registration on the WebAuthn library, taking the user object, which is the thing that gets sent to you from the device. You create a challenge, which you then save in your session and return it. The user then signs that challenge and sends it back to you to the second endpoint, which you then retrieve the information from the session, verify it calling finish registration, and assuming everything's okay, you could then save the credential on the database because the user has now been registered, and you can go through and return them a API token or however you're doing your authorization or your authentication currently for the rest of your endpoints. For authentication on the server, it's very similar. You have two endpoints again. You have the first one, which is authenticate, where you create a challenge and you return it to the user to sign. And then you have your second step, where you get the authorization challenge from your session. You have to make sure you get all the information from the user. And then you look up the database, in the database, the WebAuthn credential using their user ID from the information that they send you. And this is where you get the public key from the database. And then you can call WebAuthn.finish authentication and call the API that basically checks, does this public key match with the signature that I know for that user ID? Assuming it works, you can then give them a token again, and it all works fine. So, some resources. I've built a demo Passkey site, which you can go to on demo.passkeys.brokenhands.io. You can register with your device, try out the password flow, the passkey flow, sorry. Accounts will be valid for 2 hours, and then it will delete it. So if you're trying to log in 2 hours later, that's why it won't work. You will need to delete your passkey off your device if you try later on and then re-register. But it's a great demo for showcasing how easy it is to both register and sign in using passkeys. There's a newly released resource from the WebAuthn spec, the FIDO allowance, called Passkey Central, which goes through everything that you'll need to know for implementing passkeys in your company. So if you need articles and tutorials to show your PMs and your technical managers to say, look how easy it is, look how secure it is, this is the place to go. And then in DubDub 2022, there was Meet Passkeys, the session, which contains all of the code that you saw for the iOS stuff here, and it goes through how passkeys work and how you can implement it in your iOS apps. But it is pretty simple. It's a little bit more complicated building it in the iOS apps than, say, password flow, but it provides a much better experience for your users and a much safer experience for your users. Thank you very much. Well, questions?
Thank you. So, as a developer, how quickly should I be implementing passkeys? Is this a do-it-soon thing, or it's coming, I should get ready for it?
The general consensus is that you should start migrating to passkeys now. phishing attacks and security issues are never ending and always increasing. So if you can provide a safer experience for your users, you should do it. And certainly most companies have legal requirements around storage of user data. There was the new EU laws that were announced last week about ensuring security of your websites and stuff. This is a great way of kind of improving that. The difficulty is migrating existing users from passwords to passkeys. That's a little bit of a more tricky problem, and you have to build kind of custom stuff to essentially, once they log in with their password, saying, would you like to create a passkey, go through the whole registration flow and set it up. So I suspect there'll be a period of a long time, sort of several years of websites using both passwords and passkeys and offering it until we eventually transition. It is the future and it will happen, but it's going to be a slow process.
How do you get users to move? Because a lot of them, I hear this a lot, it's tied to my device. If I lose my device, if my device dies, I have to do a whole bunch of things again.
So part of it is education. So you teach them, there are solutions to all the problems that you have. It's not that bad. And if you really have to, you can say you can't log in until you create a passkey. If you have requirements that you need to be secure.
So you showed a process by which, from the client device, something has to be sent back to the server to authenticate. How is that step not spoofable? Like if they don't actually go through the authentication, because all the public key is the only thing the server knows. What keeps that from being a spoofable step?
You mean the registration step? Because the server sends a challenge to the user that it has to sign. So that it's essentially log in with a, during a registration request. So you have to go through the whole flow of proving that you own that public key, or that private key, sorry, with the public key. But it's the same with if you're registering as someone else. If you're on device, then that's your device essentially. So you should be the only person with access to that device. So that kind of proves your identity.
Thank you. Questions?
Yes.
Hello? You might have to shout.
Okay. Last year when I was looking at the passkeys,
Yep.
there was a problem with cross-OS passkeys, where you have an iPhone, you create your passkeys, you move to Android. What do you do with your passkeys that are in the keychain? Is there a solution for that?
Yes, don't move to Android.
Windows Phone.
So 3 weeks ago, the FIDO Allowance announced a new specification for sharing passkeys between devices. So if you want to transfer passkeys from, say, iCloud Keychain to 1Password or to Windows, whatever they call it over there, there is a specification specifically for doing that to allow you to migrate between different accounts and share accounts. No.
One last question. You have to store the domain in the server, like a room for 1Password. It stores like the whole domain and the path. Do you need to store only the or also the subpath? Wow. Do you need to store only the host, the full domain? Or
Is this on client device or on the server? On the server, you don't.
server knows the domain?
Yes. So the client device, you don't actually do anything. It's all done by the OS. So if you're implementing passkeys on a website, there are APIs via the browser that will save the domain that you're currently registering on and store that passkey and send it to the OS to say this is the domain for that passkey. On iOS, it's all done via the authentication services framework.
The travel microphone's now working if someone else has a question.
One thing to add to that as well is on iOS devices, you have to implement the well-known app site association file, and that's how the OS or how iOS knows that your app is registered to the domain of the server, because it will do that check first to make sure that you have the bundle ID on that server.
So I had a question. You said that passkeys are simultaneously shareable, but also phishing resistant. That seems incompatible in my mind, because phishing is fundamentally a social engineering attack. You convince the user to just give you the key because you pretend to be someone else. The magic of a YubiKey is that it's a hardware key. The private key never leaves SEP. So I can't I have to physically hand you my key.
Yep.
So if it's a software key, what prevents that from being phishable but also simultaneously being shareable?
So the way that the shareable stuff works on Passkeys is all done by proximity. So you have to be, when you're sharing Passkeys, say, through a website, through your phone, it creates a Bluetooth connection. And so you have to be within Bluetooth range. So if you have a man-on-the-middle site that's in a data center somewhere, it won't work. Obviously, there's still the old-school attempt of getting a hammer and smashing someone to make them do it. But it works with anything. If you have a YubiKey, you can just take the YubiKey and put it into your computer. So that's the kind of unfishable part of it, is that the device, the OS or the browser will check that the domain matches what you're trying to register for. So if you're trying to go through a domain that's spoofed, it will just not allow that. The social engineering attacks generally are done by distance-wise, so you're not being spoofed socially. Social engineering attacks are still a thing, and Passkeys won't solve that in the same way they won't solve someone threatening you with a hammer.
Someone else?
Cool.
I'm warning you, Jeroen has a book with him if you don't have other questions.
There is one up there. There's one behind you.
In the middle there, on the left.
Hey, there must be some hardware limitations. I guess I can't use my Windows 8 computer and my iPhone 5. So what are requirements that this Bluetooth connection can work?
That's a very good question, actually. So I think anything that supports iOS 16 will support Passkeys. I think it's iOS 16. Windows, you need the Windows TPM, the secure module, and I think it's Windows 10. Don't quote me on that. But that is a good point, is that if you want to support devices that are older and that you still support iOS 15, you won't be able to implement Passkeys or have Passkeys as the only authentication experience until you're up to that point where you can.
Thank you.
Someone else?
No?
So I would love to adopt Passkeys,
Yep.
and I try to convince my product owner, but they're not quite convinced that end users who are accustomed to username and password will get it. So do you have any tips how to create a great user experience and how to onboard those maybe non-technical users to Passkeys, convince them that it's easy?
Yeah, so that's a good question. So there's definitely an instance of education and basically retraining users who have spent all their entire lives doing username and passwords. There's a barrier to entry to that. We're starting to see many bigger websites support Passkeys. So Amazon now supports Passkeys. Google accounts now support Passkeys. iCloud supports Passkeys. When you sign into your developer thing, you can do it via Passkey. So once people start getting used to that, there's definitely less education that's needed. In terms of great user experiences, GitHub have got an awesome passkey flow and also a passkey migration flow as well. So if you want something to model, that's probably one of the best websites out there that have implemented passkeys in a really simple way. The demo website is also super simple. Like you saw in the demo, I couldn't even talk quick enough, and that was all in real time. That wasn't sped up at all. So I think once you've kind of shown how simple it is to register and log in using passkeys, people will get the idea. Would be my suggestion, yeah.
It's something that I think our community is going to have to lead the way, because we've been dealing with things like Authenticator, and we can feel the pain of those things. And so, but if you follow Apple people on social networks, they're pushing it pretty hard.
Yeah, like Ricky is well
Mandela,
behind it and pushing it. Yeah. And users are getting accustomed to two-factor authentication using the Google Authenticator app or SMS or tokens or whatever. Passkeys kind of pull that all into one. So if you have a requirement where you have 2FA, and if you're using passwords, you really should have 2FA, then you can say, look, this is a better experience because it combines them together.
Great, thanks. We have one more question.
Anyone?
Yeah.
Over there, maybe?
Okay.
Take that question.
Yeah?
Did you just ignore Bart?
Yes. No, he's told me to go to this side.
Okay.
Thank you. Maybe a simple question, but the flow with that QR code that you need to show, is
Yeah.
that something that you get out of the box with those frameworks, or do you
Yep.
need to build it yourself?
No, it's out of the box, done for us. So it's basically a browser thing. So if you are logging into a browser and you don't have access, there's no passkey saved on that device. You'll see it on Safari as well, in that you'll say, do you want to sign with a passkey or do you want to sign with a different device? If you click different device, it will pop up a QR code, and that's all handled by the browser. You don't have to do anything of that as an Apple website.
Okay, thank you.
So a final question, Ethan. I was just wondering, so normally a password is like one, and unfortunately sometimes too many websites.
Yep.
We reuse the password. But now it becomes really that simple to register. So what happens if somebody on, for instance, an Android tablet uses a passkey and then also uses his iPhone to connect? Because he can register again. So now there's two email addresses or two passkeys basically registered to the same user. And basically you could have a correlation behind the scenes that it's the same user because they are expecting the exact same info. So aren't we increasing the complexity because it becomes too simple to register?
It depends if you want to support multiple passkeys for accounts, and that is something you can do. So if you have like a shared account that's like a let's say company Blue Sky profile where you want to support multiple people being able to log in with the same account, you can build the flow so that when you look up the username in the database, you pull all of the public keys and store all of them as like an array, and then check them one by one. That's definitely possible. For most people, you want one passkey per user. And if you have an Android device and a tablet, for instance, like an iPad, then you should use something like 1Password that works across devices and will sync your passkeys across your different devices.
Yeah, so I understand, and I think most people in this room do.
Yep.
But I'm just wondering about the general public that already struggles with passwords.
It's an education thing again. Like if they're used to password managers, or I guess they'll become passkey managers, then yeah, it's just an education thing saying, save it in 1Password, pop it up, and thing. It's an important thing to note as well is that you're on iOS, certainly on your passkeys are synced to iCloud Keychain. So when you register a passkey on your Mac, it's automatically synced to your phone, so you can log in with your phone with the same passkey.
What a fantastic way to start day 2. Please thank Tim.